Hi 8th grade, this is Miss B here with lesson 6.2, and today we're going to be using the Pythagorean theorem and its converse to solve real-life math examples. So let's begin by reviewing our do now. So for our do now, we have triangle with leg lengths 3, 6, and a hypotenuse of length square root of 45. And we're asked if these three sides form a right triangle. So we're going to be using the converse of the Pythagorean theorem to determine whether or not these three sides in fact are going to form a right triangle. So as with any Pythagorean problem, we're going to start by writing down the formula. A squared plus b squared is equal to c squared. Our next step is to substitute the legs. So we're told that we have legs 3 and 6. So a and b are our legs. We have 3 squared plus 6 squared is equal to the hypotenuse, or c squared. So our hypotenuse is the square root of 45, and we are still squaring that term. Notice your exponent goes on the outside of the radical. The radical is just another way to say square root. It does not go on the inside. We're not squaring 45 and then taking its square root. We are squaring the square root of 45. So let's evaluate now and see what we end up with. So 3 squared is 3 times 3, which is 9. 6 squared is 6 times 6, which is 36. And when we square a square root, we're simply taking what we have under that radical sign, which is a 45. So 9 plus 36 and 45 on the right. So if we simplify the left-hand side, we get 45, and we have a 45 on the right-hand side, which is a true mathematical statement. 45 is equal to 45, so we've used the converse of the Pythagorean theorem to prove that, yes, these three sides do in fact form a right triangle. So let's take a look at some word problems together, and what's going to be important about these word problems is we have to somehow visualize or draw out a right triangle. So in example 1, it says to get from point A to point B, you must avoid walking through a pond. To avoid the pond, you must walk 58 meters south, so we're going to be walking down, and 82 meters east. So we're going to walk down and then to the right. So if you notice, we've already formed some type of right triangle here. To the nearest meter, how many meters would be saved if it were possible to walk through the pond? So we're going to imagine that we can either walk on water or float above this pond. So we have this pond, this body of water. And we already know the direction that we're walking in. So point A must start somewhere over here. Let's make that a little higher. And point B is going to be directly across the pond. So we're walking 58 meters south and 82 meters east. And if we were trying to figure out what the distance would be to go through the pond, it would be this diagonal right here, which in this case would be the hypotenuse of this right triangle. So we're going to label our sides. So our two legs are A and B, and our hypotenuse is represented by C. So we're going to write down the formula. A squared plus B squared is equal to c squared, and we're going to substitute our values. So 58 squared plus 82 squared is equal to the hypotenuse squared. So as you're solving these in your calculator, pause the video and unpause for the final answer. So the hypotenuse, or the distance across the pond from point A to point B, is about 100 meters. Now the question is asking how many meters would be saved if it were possible to walk through the pond. So if we went south and then east, we would be walking a total of 58 plus 80, 140 meters. And the difference between 140 and 100 is 40 meters. So that's how long of a distance we would be saving if we could walk through the pond somehow. In example 2, we have a group of cyclers that ride 12 miles north and 4 miles west. So 12 miles north, we're going to be traveling up, and 4 miles to the west. So we're going to go up and to the left. So again, we have some type of right triangle forming here. What is the shortest distance to the nearest tenth of a mile to return to their starting point? So the shortest distance, instead of going backwards, instead of going east and then south, the shortest distance would actually be for them to go diagonally. So we have our right triangle. So let's clean this up a little bit now that we know what it's going to look like. So they would be starting somewhere down here, and they would travel north 12 miles. Then they would be going west for 4 miles, and we need to figure out what the shortest distance going along this diagonal would be. So again, we're solving for the hypotenuse in this case, and 4 and 12 would be our legs. So pause the video, find what the distance would be, and unpause for the solution. So the exact distance would be the square root of 160, and the approximation, rounded to the nearest tenth of a mile, would be 12.6 miles. That would be the shortest route. And finally, let's take a look at example number 3. In number 3, we have a rectangle that's 18 inches high and 27 inches wide. What is the measure of the diagonal of the rectangle? So let's draw out the shape that we have here, which is a rectangle, 18 inches high, 27 inches wide. And we are looking for the measure of the diagonal. So in any rectangle, we have square corners. So we have right angles in each of these corners right here. So what are we solving for in this case? Well, we have our two legs, 18 and 27, and if we're solving for the diagonal, we are looking for the measure of the hypotenuse. Pause the video to work out the problem on your own and unpause it for the solution. So the exact answer in this case is the square root of 1053, and the approximation rounded to the nearest tenth would be about 32.4 inches for that diagonal. You'll be spending the next 30 minutes of our morning class working through the next few examples. You should get at least 6 done in the next half hour. So the most important thing with these word problems is to figure out what this right triangle is going to look like and labeling the actual sides. Are you given 2 legs and have to solve for the hypotenuse, or are you given the leg and the hypotenuse and need to solve for the other leg? Draw the picture, label the sides, write down the formula, and substitute carefully. Have a great day.